Welcome back to Chemistry Lab. Today's topic, molecular modeling. You'll be drawing Lewis dot structures, which I'm sure you've been working on in class, and using a program in lab called ChemDraw to represent them. This is what you see when you open up ChemDraw. I'm going to walk through drawing the structure that you have instructions for the first one on your lab manual. You click on the screen to get a bond to show up, a chemical bond. Go over and select the letter, the text A, and come back until the end of the bond shows a little box indicating you've selected it. And type a C for the carbon. Move the cursor to the other end of the bond, type and put in an H. So this is a carbon-hydrogen bond. Go back to the selection, go back to the solid bond tool, select that, and put the other three bonds on the carbon, and you'll see what's happening here. I get a total of 4 bonds on our carbon. And then we'll go back to the text tool and select the ends to put the other atoms in the structure. We've got chlorine, 2 chlorines, and 2 hydrogens. Now to put the lone pairs around the chlorine atoms, we have to go to the lone pair tool, which can be found by clicking on this circle with a positive charge and holding it down. Go across here till you see what looks like a lone pair set. Now if I go back, and when the blue box shows up on the atom, if I just click it, there's a lone pair, and we need 3 of them, so just click it 3 times. So here's a Lewis dot structure that works for this compound. What we want to do is look at this in 3 dimensions, so we need to open the next program, which is ChemBio 3D Ultra. You may have to go find it in the program list. That's what I'm going to do here. It's under ChemBio Office. Whoops, and there is ChemBio 3D Ultra. Okay, there it is. I'm going to move it over a little bit. And so now I come back to ChemDraw. What I want to do is to select all and copy. Bring it back up bring back up the Chem 3D program and paste. There it is. It looks at the moment like there are only 3 bonds in this structure, but if I select the rotate button, which is this one up here, select that, then I can drag it and move it around, and you can see that we have all 4 bonds, and we got a 3-dimensional representation of our structure. In one part of the lab, you'll need to determine the length of the molecule. In order to do that, while you are still in rotate mode, you click on one of the atoms and then move the cursor to another atom, and in the box you'll see the length in angstroms, 2.407 angstroms. And you can move the cursor to another atom to see how that length changes. And what you're looking for is the longest length to report as the length of your molecule, and it looks like that's what we see here from chlorine to chlorine, 2.932 angstroms. The reason you're looking for the length is that you're trying to determine if these molecules will fit inside a clathrate structure, which is sort of a soccer ball-like structure that has a pore size of 4 angstroms. If the molecule is shorter than 4 angstroms, we're going to say it fits inside the structure. If it's longer, then it won't fit. Don't forget to answer the pre-lab questions, and have a great lab.